All right, well, here I am, back again. This time the product rule. So let's talk about the picture for a few seconds. Uh, this summer we went to Disney World. We stayed at the Fort Wilderness Campground and Resort. And one of the things about Fort Wilderness is it's huge. As far as the campground goes, about a mile across, and people go around the campground on golf carts. So there are golf carts everywhere. They rent them. There's hundreds of them, and everywhere you go, you're not supposed to drive around. But anyway, one morning I was walking along, and I happened to come across this tow truck designed specifically for towing golf carts. So I thought that was pretty cool because the golf cart's not that big, the tow truck wasn't that big. It was just it's like I'd stepped into a miniature world. And so somebody makes that. Somebody makes the miniature golf cart tow truck, and somebody makes everything, and everything that someone makes is a product rule. That's the stretch. Long story, but still kind of a funny. Yeah, there it is. I don't know how to get rid of that. So, product rule. Here it is. It looks like this. If we want to take the derivative of one function multiplied by another function, we take the first function, multiply it by the derivative of the second function, and then we add to that the second function multiplied by the derivative of the first function. So we're going to say that, and the way the sort of the mantra that we have going on for this is the first times the derivative of the second okay, so the first times the derivative of the second plus the second times the derivative of the first. Okay, so we want that to get into our brain. So the first times the derivative of the second plus the second times the derivative of the first. Say that a bunch of times. The first times the derivative of the second plus the second times the derivative of the first. Say it with a British accent if you like, if you need to, you know. The first times the derivative of the second plus the second times the derivative of the first. Okay, so might hear that. Whatever accent you need, but just keep saying it. The first times the derivative of the second plus the second times the derivative of the first. That's the product rule. We need to get that into our brain. The first times the derivative of the second plus the second times the derivative of the first. That's the first. That's the second. Let's use the product rule to find the derivative of this thing. So we write down the first times the derivative of the second. So what's the derivative of 4x minus 2? Why, it's 4. Plus the second, 4x minus 2, times the derivative of the first. What's the derivative of this thing? 6x. Okay, first times the derivative of the second, plus the second times the derivative of the first. So we got to do a little more work here because that's ugly. It doesn't really help us figure out, what the value of the derivative is if we needed it to find the slope of a tangent line or anything like that. So we'll do some distribution, 12x squared plus 20. And probably 24x squared minus 12x. Does that seem good? And we'll make it look all nicey nice. How about 36x squared minus 12x plus 20? Seem good? There it is. The derivative of this, it's this. So, first times the derivative of the second, plus the second times the derivative of the first. So we're going to check that because we know we could have probably multiplied those things together first. So we'll do a rewrite. We'll do the Dora the Explorer version. We'll do the rewrite. So the rewrite's going to be, what, 12x squared plus 20x minus 6x squared plus minus 10. Am I right there? 12, 3, 4, 12. Oh, how about that's 12x cubed, Mr. Dig? Yeah, that's what that is. That's cubed, right? Squared times that. 12x squared. That's why we're precise. We check our work. We make sure we didn't do anything dopey. All right, so now we can take the derivative of that, I think, pretty easy. Y primed equals, is that going to be 36x squared? I'm going to do this sort of out of order. Minus 12x, and then plus 20. Okay, gosh, I hope that's what we wrote down on the last slide. It is, yay for us, okay? So we got the same derivative, so this time we multiplied first and then we took the derivative. This other time we used the product rule. If you have a choice, whichever way you like. You want to do the algebra first and then do the derivative? Great. You want to use the product rule and then simplify? Great. Whichever way you like. Sometimes you have a choice. Sometimes you don't. Okay? Sometimes you feel like a nut. Sometimes you don't. So in this case, there's no way to simplify this, so we got to have at it with the product rule. And the way I would go with the product rule is that the first term is that, and the second term is that. Okay? So sometimes the biggest problem people have with the product rule is not recognizing that we actually have a product. We're actually multiplying two things together. So we are multiplying, in this case, 5x cubed by the cosine of x. So let's get at it. First times the derivative of the second plus the second times the derivative of the first. The first is this, 5x cubed. Derivative of the second, what's the derivative of cosine? You should know, negative sine of x. Plus the second, cosine, times the derivative of the first, which is going to be what, 15x squared? Okay, we want to try to make that look nice. What we do when we're making it look nice is we usually have like negative signs if we have those out in the front. So negative 5x cubed sine x. And then we usually put algebra functions in front of trig functions so that, well, let me write it and then I'll show you why. Okay, so we put the algebra function out in the front. The reason is because somebody could come along and think, oh, this is the cosine of 15x cubed because it's x and 15x squared. So if we have it in front, people should not make that mistake. All right, first times the derivative of the second, first times the derivative of the second, plus the second times the derivative of the first. Away we go, okay? And the reason for bringing that minus sign out there is so somebody doesn't come along and think it's 5x cubed minus sine x. So it's clear that we're doing the multiplying, and off we are, okay? So if you don't have a choice, you got to use the product rule, which of course is the first times the derivative of the second, plus the second times the derivative of the first. So all my trig functions have derivatives. We know the derivative of sine is cosine. We know the derivative of cosine is negative sine. All these have derivatives, and let's go through what they are. So the derivative of tangent is the secant squared of x. The derivative of cosecant is negative cosecant x cotangent x. The derivative of secant of x is secant x tangent x. My brain skipped there. And the derivative of cotangent is negative cosecant squared of x. Okay. So the thing to realize, there's some patterns. All my cofunctions, if you notice, have negative derivatives. The ones that are sort of alike, cosecant and secant, have a similar form. Tangent, cotangent have a similar form there with the squares. Okay, what's going on down here in the corner? Let's get that out of the way, see what it says. Okay, wow, that's really awkwardly printed out. It's supposed to be the monkey saying this, but somewhere in the translation from one screen to the other, the monkey's just sitting there underneath. But the main thing that we want to get to is that the monkey is saying you must internalize these things. Okay, and more than just memorize. I want you internalizing the rules because, well, because you need to, because we're going to use these forever. So internalize the rules. They've got to get into your brain. The monkey is thinking that, the monkey is saying that. Internalize, more than just memorize. Get them actually into your brain so that they're there forever. Oh, that's just delightful. What's going on? That was supposed to be so cute and clever, but alas, it was not. So, internalize them. Get those into your brain, because these come up time and time and time again. We need to be able to just quickly recall them without any delay. All right? So we use those as we're trying to find out things like, hey, what's the derivative of y equals x plus secant of x? So again, with all these things, we've got something that we've discovered that behaves in this way. We've got a bunch of data, we analyzed it, and we came up with, wow, this looks just like x plus secant of x. And so we want to know how that's changing, and the way to figure out how it's changing is to take the derivative. So the derivative, y primed, we go with what's the derivative of x? 1. What's the derivative of secant? Derivative of secant is secant x tan x. Okay, and so what we do if we're actually evaluating that, we figure out what the secant of our number was, figure out what the tangent of the number was, multiply them together, and there we go. Okay, so there's that one. What's the derivative of y equals x tan x? Okay, this is one of the problems where people say, oh, I don't know. Well, first of all, this is x times the tan of x, so we need to use our product rule. So y primed, the first, x, times the derivative of the second, derivative of tangent, secant squared, okay, plus the second, tangent, times the derivative of the first, 1, right? And then we just try to make it look nice, and there's not a whole lot we need to do to make it look nice other than maybe get rid of the parentheses, so it's x, secant squared x, plus tan x, and we're done. Okay? I'll read that. So, derivatives. Trig functions. They're on the card that I either gave you or will give you. So if I haven't given it to you yet, remind me. And that way you have them as a ready resource, but we want you to get them into your brain at some point. We're going to quiz you on whether you've actually got these into your brain and a few other things. Okay? Product rule. I may have said it before. I may have said it 37 times in this little video. We're going for 38. The first times the derivative of the second plus the second times the derivative of the first. 39. The first times the derivative of the second plus the second times the derivative of the first. I don't know if I have any other accents that I can do it in. It would be, I don't know. The first times the derivative of the second plus the second times the derivative of the first. Okay, how about that one? That's my Baba Booey accent. And that's really about all that we've got. So, thanks for watching. Hope you picked something up. I'll talk to you soon. If you have questions, well, you know that you should just ask them away. We'll see you later.